So welcome, good afternoon. This is Hit the Analytic Jackpot with Spatial SQL. My name's Sarah Battersby. I'm on the research team at Tableau, so I'm in development, but I'm on the part of development that doesn't follow any of the actual development timelines. So if you ask me what's on the maps roadmap, I'll be like, go talk to the PM of the maps team. But if you want to talk about crazy stuff you can do in Tableau, let's chat. So a lot of what I do is I like to hang out at my desk and think of crazy spatial questions that maybe you can't answer directly in Tableau, but maybe we can kind of weasel around and actually get you some cool answers. So what I'm going to talk about today is some of the work that I've been doing, thinking about how we can take advantage of the data connectors that we have with a couple spatial databases and use their spatial calculation capabilities to do stuff that we can't do in Tableau natively right now. So my goals for the talk, I really just want to kind of go into, this is an advanced level talk, but the target that I'm trying to hit is not, you'll have no clue what's going on. The target is everything from, I really don't know a whole lot about what Spatial SQL is. Can you help me out with that? Familiarity with basic queries and where they go in Tableau, and then how you can use this for some Tableau awesomeness. So I'll show you some examples. We'll build up a few things. But what I'm not going to do in the talk is build one very specific, detailed demo so that you only see one use case. I'm really going to start more from what I consider the raw ingredients of Spatial SQL, so you can see some of the range of what's capable. And then as you think about your own analytic questions, think about how do I put these pieces together to do more complex analysis. Since this audience is small enough, I'm hoping that during the talk you feel comfortable, just yell out questions if you have them. If I've done something that is totally mystifying, I am happy to kind of go off the rails. I've got some slides, I've got some demos, but if it all goes out the window and you just watch me flail through writing some live SQL queries, it's going to be all good. Because then we'll get what you guys need. We're a big, happy SQL writing family. Intended audience, just so I have a sense of what I'm working with here. How many of you guys really love writing SQL queries? Awesome. How many of you guys really love doing GIS stuff? Okay, so a little bit smaller. How many of you love both? Great, okay, so like a third is okay, you guys are my experts. You're going to help me answer questions when I get it wrong up here. How many of you guys just really like maps? Great, okay, so everybody's in the right place. Hopefully I'll hit something at everybody's target level and you'll be pretty happy at the end. So let's start out with the question of why we even want to think about Spatial SQL and Tableau. So the first thing is, we're building a lot of functionality into Tableau. We've increased the spatial functionality a lot just in the last couple years. New data connectors, new analysis capabilities, being able to take raw latitude and longitude and turn it into points, which you can then use in spatial intersections, being able to draw lines and have those lines be geodesics, being able to do distance calculations. If you watch devs on stage, you saw we're adding in buffer calculations. A lot of things that we're doing and a lot of things that we want to do to make spatial more accessible to everybody. But we're not really going to be able to incorporate everything into Tableau. We're probably never going to incorporate everything that you would have in a standard geographic information system or in a spatial database into Tableau. It's just not, it's probably just not something that's going to happen. But because we support both SQL Server and Postgres, which support geometry and geography data types, we can bring those spatial types into Tableau natively. And we can write queries against data in our spatial databases natively from Tableau, and then return the geometries or return the calculations from those. And so we're just using SQL Server, using Postgres as a way that we can create new geometries, support complex analytics, or do anything spatial that we need to in our analytics cycle, everything from data prep all the way up to the visualization and communication side of things. So Spatial SQL is going to allow us to open a lot of doors with doing more advanced analytics. Let's look at some demos, though, because it's kind of fun to talk theoretically about why Spatial SQL is interesting, but maybe we want to actually see what we can do with them. So I'm going to start out with a demo from this time that I was at a geospatial intelligence conference, which consists of generally a lot of guys in black suits and camouflage. And so what do you do at night at one of those conferences? Well, you got a couple choices. You can go to the bar that's probably hosted by a very large defense contractor and you can drink a lot. Or you can go back to your hotel room and think about how you could maybe look at some disaster data in Tableau and how maybe Spatial SQL might be kind of cool for doing that. So it turns out that's what I was doing. And so, it was hurricane season. I was in Florida. So I started thinking about, how can I get some of this hurricane data and what could I do with it? And so I grabbed some of the hurricane force wind speed probability data, and I grabbed a bunch of census data, and I started asking questions. Well, if I were in an emergency management office, what are some things that I might be interested in? Well, a real basic question is, what's the population that's impacted? So I threw all this stuff into SQL Server because at the time that was the only database that we supported. I did some intersections, I did some calculations, I made a quick dashboard, and this allows me to answer all of these questions about what is the impacted population. So I can select any one of these little bands. So here's the less than 5% chance of impact, and I know that's a pretty small percent impact likelihood, but it happened to be the time step that I grabbed, and I know that there are 9.2 million people that are impacted. I can actually get census tract level data, so I know that in this particular census tract, I could find out that there were 3,200 people that might be impacted, and I can do this cool thing because I just cracked all those polygons with Spatial SQL because I don't want to double count people, and it turns out that that hurricanes do not stop at census tract borders. I know it's kind of crazy to think about, right? But if I look at these probability boundaries, they're going to cross over borders. And I just made a little quick close-up so we can look at that. So here's one particular census tract, and this little bit of it happens to be in the 10 to 20% likelihood, and this big bit of it happens to be in the 5 to 10% likelihood. So I don't want to double count the population because that tract is being, falling into two different zones. So I just cracked that polygon into two parts, calculated the area, and then proportionally allocated the population. Easy peasy, just write a query, super easy. It actually was really easy, and I have a Python script that does all of this for me. Because what happens with disasters, turns out they put out new data every 6 hours. And you know how much it sucks to hand type all those queries over and over and over again? Even if you got them in your spreadsheet or in your notepad and you just kind of copy and paste it, it sucks to type them over and over again. But if all you have to do is say, just grab the new data and type in the new time and hit go, and it loads it into your database and does all the calculations, and then your viz updates, it's pretty awesome. I think that there is, because the data has a really standard naming scheme. So if you are smarter than I am, I think that you can write something in your Python script that just goes out and pings it and says, hey, every 6 hours or every 6 hours and 1 minute, so you know the data's there. Just go out, grab it, and then know that you update the name because the naming system is so set. What I was thinking about yesterday. Yeah, it's totally easy. Just go and do it, and then send me a note that tells me how to do it, okay? This is why I give these talks. I give you ideas, and then you do them and bring them back to me. What I was thinking is this would be super awesome if we could then combine it with something like dynamic parameters. So then when the new data does get loaded in, I just have the drop-down. I can see both the historical impacts or the current. So I can see, follow the track of the storm and how the population impact is changing over time. I could also put it together and do something like a little impact quick summary. So I could see this in my emergency operations center, so somebody could interact with any of these polygons and just see my quick, 210 counties impacted, 7.2 million households, but tell me about this particular area right here, the 20 to 30% likelihood. It's only 777,000 people. Or I could then pair this up with other data sets, like tell me all of the shelters that are in the counties that are impacted, or the contact information for every one of the emergency operations centers in each of those counties, and have that all just run through Tableau. So that's a fun thing that we can do. Let's see what else we can do. Because I just had a handful of fun little demos. Nearest neighbor is something that I hear a lot. I need to know the 3 closest things to me. I need the 1 closest fire station. I need to know the closest hospital to each one of my patients. I need to know, whatever the nearest something is. So this is super easy with Spatial SQL. I'm just looking for the K nearest fire stations, and I have a parameter set up in here. So I can say instead of the 4 nearest fire stations, if this will let me type something in there, give me the 3 nearest fire stations, and it should update. And it's telling me, here are your 3 stations, 42, 43, and 44, and here's the average distance to each of them from the point that's been selected. Now, of course, I'm using a dynamic parameter or a parameter action in Tableau, so I can just pick another incident. It's going to send that query right back into my database, and it's going to tell me, okay, from that point that you just selected, I can show you the nearest stations on the map, I can tell you some information about them, and I can go ahead and draw some lines to connect them in case you want that kind of detail. We might also want to do some kind of filtering by characteristic. So this was a question that was brought to me by somebody in a hospital system. And they said, I know where all of the patients are, or all of the people in our database. I know where all of our facilities are. And I need to be able to select anybody and know where is their nearest hospital or where are the 2 nearest hospitals. But I also need to be able to say, but only tell me hospitals that have the capability to do X. I only need places with emergency rooms. I only need places that do certain types of trauma. So this is taking a data set. This is fire stations and incidents that they've responded to. And this is showing me the nearest station for any point. So I'm just clicking on a point and having it highlight the station. Or I can click on an incident and have it highlight its little zone where all of those points are closest to a station. But I also have a filter in here so that I can choose from specific characteristics. And it turns out this is a really boring data set, but I can still change something. So this is all of the stations that have ALS, which I think is advanced life support. I'm going to ask Don if I'm right on that. Correct. All right, he's my fire guy. And we've got ALS and ILS. What's ILS? BLS. Well, I said ILS in their data set. He's our fire guy. If you got fire questions, talk to Don up front. But what just happened? So I just changed a little drop down, and now there are only 3 fire stations that are showing up. Those are my little yellow X's up there. Because the query is saying, okay, don't show me all of the fire stations, just show me the ones that have the characteristics that I want, and I can still select any incident and see every point that is closest to a particular station. So this is just doing a nearest neighbor from the points to the stations that have the characteristics that I care about. And it's all running as a SQL query. But you might actually want to know the network path to those nearest stations instead of just having a straight line that connects them. So I can go in, I can select any one of these, update my selected incident location, and it's going to use Postgres and PG routing to tell me not only what are the 3 nearest fire stations, but how do I get there. So here's station 4, here's the path to station 1, and here's the path to station 106. I would not use this for emergency routing. Please do not think that this is going to be something great for your E911 center, but if you need something graphical that is going to tell you not just where are the nearest things, but what does the approximate path look like to get to them, this is something that can be done pretty easily with Spatial SQL. You can also make things that just look kind of pretty. Like we can look at all of the nodes on a road network that are within a set distance. And I can update that distance. So let's look at something a little closer. And this is just dynamically going to query our database and find every node on a road network that we would pass through that's within 2 kilometers of an origin location. It just kind of looks pretty. You're probably not going to actually do this unless you want some bling for something. Or we could do nearest neighbor selections that involve polygons. So we've got point and polygon intersections in Tableau, but we don't have polygon and polygon interactions. So this is a way that you can get that type of analytic. So what this demo does is I can click on any one of these county polygons. It's going to buffer out a set distance, which I can control with a parameter, and then it's going to tell me everything that's inside that polygon. So here is, we're looking at Dundee County. We can look at all of the neighbors, and this is just telling us the land area of the polygon and whether or not they're larger or smaller than the selected polygon. So it's telling us something about the neighborhood. There are a couple different spatial operations that I can use. This is telling me a contains. So when I look at the buffer that's being drawn, and that is the blue polygon that's being drawn around the county, every pink county is completely within that buffer. But I might want to be more generous. So instead of doing a full containment, I might want an intersection. So this is going to select every county that even touches that buffer. Or I could do something totally crazy and say, I really just want everything that is directly adjacent. So this is just a touches. So if I need to know something about the neighborhood for any given polygon, this can do the calculation for me. And it's just passing it back and forth to Postgres and returning back the table that tells me I'm a neighbor or I'm not a neighbor. Now, of course, this is completely dynamic in Tableau, so I could pick another county, go ahead and update. It's going to go ahead and pass that query back to the local Postgres database that I have on my laptop, and let me do any of those operations. As in, like, like go out 2 levels? Yes, I think I can. It would be a different query. I'm not going to try it live, but I'm totally happy to try that when I'm in my office. Yeah. So the question is really, I've got 1 level of what this touches. Can I do? I want everything this touches, and then everything that touches that next level out. So with this, I can also adjust my buffer. So here's 150 kilometers, 200 kilometers, 250 kilometers. It's completely dynamic. So I'd be able to assess all sorts of different characteristics about my neighborhood and define my neighborhood in a lot of different ways. So let's just jump back to the how did all of this happen, in case you wanted to know. The hurricane data set was really all pre-processing. I had a Python script that ran all of that through, used SC intersects and ST area. So ST is a spatial transformation. It's just what you put at the beginning of the spatial functions that you call. And that's all I needed to do all of these calculations. The k-nearest neighbor problems is ST distance, so it's really just a distance calculation. It's using ST buffer, so buffering out a certain distance, and then using something called PG routing, so that's the Postgres routing tool, and OpenStreetMap data. So all of that data was free. The road network, totally super easy and free, easy to get into the database, and really easy to write queries against. If you came in a little bit early, you may have seen my wind speed and direction demo, which I put up just because I think it's kind of pretty. And it looks like it got kind of washed out here, but it's super pretty looking. I just got a bunch of wind direction and wind speed data, and I drew some lines, and I rotated them, and I changed their length and changed their thickness, and it just made something really pretty looking. And you can write Python and have it all happen. Don't try and write any of this down or take notes or take too many pictures, because I wrote 10,000 words of blog posts on all of this, and I'll show you where to get them. The county example, ST buffer, ST intersects, ST contains, and ST touches. It's really just 4 functions, and I'll show you how to build that up. So don't take crazy detailed notes, because I really did just put all of this up on the community forums in Tableau. And here's the bit.ly link to it. You can also, if you just go to the community website and you search for map, anytime you search for map, up at the top of the results window, there is a map frequently asked questions box that shows up. Someone foolishly gave me permissions to edit things on the forums. And so I put my blog posts in there and a direct link to my blog. So if you search for anything related to maps, you can always find my stuff. Turns out that one of my neighbors used to run some stuff on the community forums. And he's just like, oh, sure, I'll just hook you up with some kind of masterful powers. I don't even know what I can do, but he told me not to abuse them. So I try not to, but I try to make sure everybody can find these blog posts. So there are 8 different blog posts, and I'll go ahead and just, I think I loaded it up just so you can see what the latest thing is. Yeah, if you go to, here's the maps FAQ. So you can take a look at that, or I have no mouse on this screen as far as I can tell. There we go. Here is the Spatial SQL overview. So I wrote an overview post that just has links to everything that I wrote. So putting data into the database, identifying and updating coordinate reference systems, because that's probably the question that I answered the most about spatial data. My map projection is wrong, can you help me? Spatial indexes and why you should care. You should create them. It probably won't hurt you. It'll probably only make things faster. Just do it. End of that story. Calculating geographic properties. I have a whole lot of examples of things that you can calculate. These are the raw ingredients. Some doing intersections, containments, and other fun things. And then a couple k-nearest neighbors posts that'll do networks and just closest in Euclidean distance. And then there are some old posts that I've written over the years, including one of my favorites, which is how you can do a dot density map. Should you ever want to do that in Tableau? It's kind of cool. One of our Zens challenged me to do it, so I was like, okay, sure, that sounds fun. So there you have it, lots of blog posts, and hopefully they will be helpful for you. So don't feel like you have to write down like super crazy notes. Some references that I like if you want some other tutorial information. I started working with Spatial SQL after doing this Boston GIS PostGIS tutorial. I thought it was pretty nice, easy to go through. And then I tend to keep the PostGIS cookbook on my desktop because I feel like it's got a lot of really nice examples. And the stuff that I use that is not SQL related, I tend to use Tableau just to even see if I can open data because it's a pretty nice way of just eyeballing what's in a data set. I use QGIS quite a lot, which is a free and open source GIS package. It helps me understand a lot of whether the spatial data is weird or to deal with spatial intersections that may make it so that my database freaks out if I try and put spatial data into it. GDAL is what I use for most of my file format conversions and for pushing data into the database. And I can't help myself. I try and automate a lot of things. Python's great for this, and there are a number of really good libraries you can use that'll allow you to interact directly with your database. So you can run queries via your Python script to process your data. Absolutely. And I think these slides are made available after TC, and I can send you the links to any of these. Feel free to reach out with email. You can also just search for the Boston GIS tutorial. It's like the first thing that shows up. Super easy to find. So what can you do? A whole gigantic ton of things. Yeah, this took me like multiple screen captures to get the whole list of functions. But if you could do it in a GIS, you can probably do it in your spatial database. It's just a matter of figuring out how to write the query. One last set of important points before I launch into just like doing a bunch of like live SQL writing, which terrifies me, by the way, because typing in front of even like 50 people is really hard. Heaven forbid I had to like type my password in or something in front of you, because I'd fat finger that like 20 times and I'd get locked out. So watching me write SQL, we're going to hope this goes okay. So I'm stalling. I'm stalling by talking about coordinate systems. Something you really need to know is that with spatial databases, Tableau only supports 3 coordinate systems. If you're bringing in data from other spatial file sources, so long as we can recognize the coordinate system, we'll just ingest it. Doesn't matter. But if it's coming from a spatial database, it needs to be in one of 3 coordinate systems. Either NAD83, that's the North American Datum of 1983, ETRS 89, the European Terrestrial Reference System of 1989, or WGS 84. I would highly recommend that you write down these EPSG codes and just sticky note them to your monitor or just memorize them, because you're going to want to use one of them. And in terms of memorizing them, probably just memorize 4326 because it's easy. Yeah?
So we're a Microsoft shop. We have a lot of spatial data already. We're using geometry data type, and it's all 3857. It seems like you're outputting 3857 instead of all this map box stuff. So why is 3857 not supported?
Okay, so the question is, we're getting like super nerdy here, because like the question was even asked as, why is 3857 not supported? So let me translate that into English. Why is Web Mercator as a coordinate system not supported natively? Because that's the coordinate system that you use in Tableau when you show me that really awesome Greenland is huge map. So we're going to translate all your data into Web Mercator. We're going to translate it into 3857. We're going to translate it into Web Mercator, which now it's like I cannot say like the EPSG code for. The reason that we do this is these are the types that are supported for geography. So the geography data type is the spherical coordinates, and we want to do all of the analyses as right as we can. So we're actually going to do your analyses on spherical coordinates whenever we can. And SQL Server, which is the database that we supported first, really loves spherical coordinates for all of the calculations. So we said, hey, you know what? Bring us some latitude and longitude. Bring us some spherical coordinates, and we'll do the magic from there. It was a decision that was made because we felt like we knew that geography was the rightest of the rightest of the geographic data types.
Is there any intent to kind of open that up? Maybe consider going with 3857 as an option?
It's a good question. I'll bring it to the maps team. It is outside of my area of influence. But anytime you want to talk about Web Mercator, I do love Web Mercator, so happy to chat about that. So map projections are kind of my thing. Really kind of like them a little too much. Just wrote a book on them in case you want to talk more about map projections. Like, really, they're my thing. But this led us to talk a little bit about geometry and geography. So the spatial databases will often support two different ways of storing the spatial data. Geometry, which is planar coordinates, and geography, which is spherical coordinates. The calculations you do on those are different. If you're working with SQL Server, we're only going to ingest geography data types. We are not going to ingest geometry data types. So that's probably your answer on why we don't take 3857, because it's geometry. So you got to convert that into a geography type. Postgres, on the other hand, Postgres is all like plays all loosey-goosey with geographic data, which is probably why I use it a lot, because you can do really bad things with it, but it's really like easy. So we can take both geometry or geography data types from those. So just so pay attention to your coordinate reference system and your data type, whether it's geometry or geography, and it's going to vary by spatial database what we support. So let's do some live demos, because that's going to be more fun than my just talking about random things. So we're going to start with the question of where spatial SQL goes. How many of you guys have used custom SQL or initial SQL in Tableau? Most of you. Okay, so I'm going to blow through this kind of fast because most of you are going to be just like, whatevs, been there, done that. But for those of you who haven't, I want to make sure that you understand where you can even put these queries and see how easy it is to get things working. So I'm going to go ahead and grab some. I'm connected to a database that's running on my local computer here. Let me see if I can just show you. This is just running from localhost. It's a Postgres instance. Nothing special. And I'm connecting in, and it shows me here's a list of tables that you have. I'm going to go ahead and grab my Las Vegas fire stations. This will look just like any other data source. Hey, look, it's just a table. Nothing real interesting here. No SQL involved. I could use custom SQL instead. And I'm just going to do select star from Las Vegas fire stations. Nothing real interesting here either. I'm just saying give me everything that is in that fire stations table. I've already filed a defect on this. I don't know why Tableau will change the active window when I hit OK on a custom SQL, but don't worry, the defect has been filed. So I apologize if that happens a bunch while I'm writing queries. But what is the result of that? Hey, look, there's a table. It looks just like the table that I dragged in. Nothing real exciting. But because I can write SQL queries, instead of saying select star, I could say select anything I want. Select the buffer of something, select some calculation of something. Do something like, let's just get a subset of these. I'm going to order by random, and we'll do that intentionally so you can see what happens. And I'm going to limit 3. So this is saying just give me 3 records. No, we won't be doing a lot of that, don't worry. And it's just going to give me 3 records. But what I want to show you about what happens with this custom SQL query, so I'm going to drop my geometry onto the viz. I've got 3 data points that show up, and I'll make them a little bit bigger so you can actually see them. And disambiguate them. Okay, we got 3 fire stations. I'm going to zoom out a little bit, pin the map. And what happens with custom SQL queries is it's kind of chatty. So every time you change anything about the visualization, it's going to rerun that query. So if I want to drop something else on detail, I just got 3 different stations. Let me drop something else, 3 different stations. Why am I showing you this? It's not because, hey, isn't it cool? I can get 3 random stations every time I interact with my visualization. It is, know that if you're running something through custom SQL, it's going to run a lot. So if you're doing something that takes any time, it might slow things down. But you get some advantages to running things as custom SQL. So instead of saying limit 3, I could drop a parameter in there instead. So create new parameter, how many stations? And we'll just make that an integer, type in any value we want. Current value is 1. Great, I have 1 station. I have 1 different station. I have 1 different station. But I've got this parameter, so I can show that parameter control. How many stations? I don't know, give me 5. Okay, cool. It'll go back and query for 5. So if you want to do something like have a dynamic buffer, you want to have a dynamic selection, you want k nearest neighbors, and you want to update how many neighbors you get at any given time, you want people to interact with it, custom SQL will let you do that. If you do not want this to be chatty, initial SQL is great. So let's just see what that would look like. I'm going to edit this and just copy it so I don't have to type it in again. And from my connection, I can type in an initial SQL query. I'm just going to put that same query right in there, but I can't use a parameter anymore. So I'm just going to go ahead and limit to 3. But I need to, since this is initial SQL, I actually need to create it as a temporary table. So it's create temporary table. I'll call it fire stations because it's easier to type. And every time I open the workbook, then it will run my query. Yeah, see, live typing is hard. Now, I don't have this fire stations that shows up in my table, so now I use a custom SQL and just say, okay, select star from fire stations, and I am going to get a data set that just has 3 stations, and it is never going to change because it's going to run that once when I open the workbook. I can drop anything I want onto detail. I can change the color, and it's still just going to give me here these 3 things, even though it's ordered the table randomly. Another place you can type in your SQL queries, I'll do this as a calculated field. And we're going to make a random number, because that's pretty exciting too. So you can run these RawSQL queries. And what this is saying is on a row level, I'm going to type in this query and just go ahead and feed that right back into my database. So I'm going to do RawSQL, and I'm going to do a random times 10. And what this should do is just give me a random number. And I'm going to drop that random number. We'll put that on as a label, and we'll make that label big so you can actually see it. And let's see what happens when we change our visualization. Notice those random numbers are now updating. So RawSQL is also going to run every time you update the query. So that's the thing to know. There are 3 places you can put your queries. Initial SQL is going to run when you load your workbook. Custom SQL is going to run every time you update your query, but you can type in more complex queries. RawSQL is going to run pretty much row level every time you update your visualization, but it allows you to do these quick calculations where you're just like, I just need the area of every polygon in my data set, and it'll just spit right back into your database and be like, great, I've got all those for you. You don't have to go back in and edit a longer query in initial SQL or in RawSQL. So I generally use RawSQL when I forget to do things in advance. It's nice for that. It's like, oh, I'm doing a demo. You know what I forgot? To calculate the area for everything. Okay, so let's just do some basic calculations since we've got our data set open. And I'm going to switch over to a new workbook because I got some stuff preloaded. So first thing, we saw some cool demos of buffer. Not in the product quite yet, but I'm going to show you how you can go ahead and do that with your data. So I'm connected to my fire stations. We're just going to write a quick RawSQL query. And I'm going to return a spatial type. So there are lots of different RawSQL things. You want to make sure you're returning the right type. I'm going to type in SD buffer, %1, and I'm going to type in a unit. How big is my buffer going to be? We're going to put in 0.001. Which sounds like a really small number, but you'll see what happens. And what field am I using? So all this is saying is go into my SQL database, use the stbuffer command. You're going to start to realize pretty quickly that if you just type st underscore and then something that sounds interesting, you'll probably get a result. %1, this is just a placeholder, and we replace that with the geometry column. 0.001 is our distance. I'm going to say OK, cool, I've got a geometry now. SD buffer, geometry, yeah. Thank you. Yes, this is what happens when I start like trying to live type things. Yeah. Well, we'll use the one that's already been created that works. How's that? So I've got a buffer that works. And I'll show you how this works. So this is stbuffer, but I'm actually doing something a little bit different here. I was going to try and show you what it looks like when you calculate it on geometry. And it calculates in this really, really useful geographic unit, decimal degrees. Does anybody know how long a decimal degree is? About yay long? Yeah, exactly. Unless you're near the poles when it's like yay long, but only for longitude. Turns out your latitude is still yay long. A decimal degree is a horrible unit to use. But if the coordinate systems that we support are all in latitude and longitude, it means that if you do calculations against those geometries, you get really horrible units. My favorite, the area calculation in square decimal degrees. That's a really good one. So the way you get around that, I'm happen to be using a geometry data type here. I could have geography in my database and use that, but I just have geometry. So I'm taking my geometry and I am casting it to geography. And then I'm putting in my buffer distance as a parameter here. So it says, give me my geometry, use this buffer distance in meters, and go ahead and calculate out. And now I've got a parameter that I can control that buffer with. And it looks almost as cool as the demo that you saw on Devs on Stage, but it's running from a SQL database instead. Gives you pretty much the same flexibility because we could use this as a custom SQL query or an initial SQL query, and then we could use that geometry to do point and polygon operations in Tableau using the spatial intersection. So easy peasy. Let's keep on going. So we could do things, instead of calculating buffers, we could do something with, let's do something with polygons. So one of the questions I get periodically is people would really like to have their polygons color-coded by something, and let's just pick something like, great, we've got our polygons color-coded by something, but what I want is I want the outline of each of them to either match the color of the polygon or to be some other interesting color, as opposed to like the single, like I can have a single black outline or white outline that I can't change the width of. It's just kind of like this line that Tableau draws that's hanging out. Hey, spatial SQL, it's fun. We are going to go ahead and calculate the boundary. Anybody want to take a stab at what the ST function is going to be? ST boundary, yeah, put an ST and then pick the thing that you want. So we can just type in ST boundary, put in our %1. So it's saying, give me the boundary of each one of these polygons. So I can go ahead and make the dual axis map, and I'm going to swap out my geometry with the boundaries, and then I could color code these however I want. I could go ahead and change their width. I want like monster thick outlines, which is going to be super awesome and cool. And we're going to make them like hot pink because that's also super awesome and cool. And then we'll go ahead and dual axis those, and I've got a really pretty map. Spatial SQL, not only is it fun, it can help you make things that are bizarrely pretty. I would like all of you to use bright pink large outlines on all of your polygons, and then maybe go in and you can do some fun stuff like some cartographic symbolization, and we're going to make them really cool, a little bit transparent, just give our polygons that nice pink glow. Okay. Like that was so exciting. So let's go ahead and I'm going to undual axis this. I'm just showing you a lot of kind of raw ingredients, things that you can play with here. So maybe we don't want the boundary, but maybe we need the centroid of all of our polygons to do a calculation. We could go in and look at what the generated latitude and longitude is in Tableau, and we could export that, and we could join it back in, because that's a really easy workflow. Or I could just go ahead and say, hey, Spatial SQL, can you just give me the centroid? And it'll just give me the centroid for those. And then I could grab the X and Y coordinates if I want. So I will show you this, and you're going to be unsurprised, but it turns out the command is stcentroid. So we wrote that query. And then we're going to get the X and Y coordinate for them. st_x, also probably not surprising. And I'm getting that from the centroid that I've already calculated. So if I wanted that point to do some kind of analysis, I want to do distance measurements away from the centroid, I have both the X and the Y, or I have the raw geometry. The %1 is this placeholder. So anytime you want to reference a field, like a dimension or a measure, from inside your data set, when you're writing the RawSQL query, you want to put in a %1, %2, %3, just sequentially go down the number line to say, I'm going to put, this is a placeholder. At the end of my query, I'm going to tell you what to fill in there. So if I say %1 for the field, and I'll just open up one of these so we can look at it. Yeah, it's arguments in order. So this is the placeholder for what, and I'm going to fill it in with whatever the first thing in this list is. And if I had a %2, it would fill it in with comma, whatever the next thing in the list was. And I think it's because when the query gets passed back, sometimes we change field names a little bit. We want to make sure that's the actual right data that's going back. So we put in this placeholder, and Tableau does the magic to make sure that the right data is passed in. So we could get things like our centroid. You can translate those. Let's see if this, you dual axis this so we can see them a little bit bigger. They're going to move. It's going to be awesome. Oh my gosh, they just moved to new locations. I just did a translation. So you can say, take that point. If I don't like where it is, shift it by some number of units. It's great if you want to do jittering of points. You want to offset them in some way. You can just say, go ahead and translate them. Using the magical st-translate, I'm just taking the centroid and shifting them by 1 decimal degree. We could calculate things like the perimeter or the area. So those are spatial calculations. They're not going to return a spatial type, but they're going to return a floating point number. So if I want to know the perimeter of any of these polygons, or I need the area of any of these polygons, I can just pass those queries in and then drop them on as, in my tooltip. So I know the area of this happens to be 60 bajillion square meters, or I can go ahead and do the math and simplify it and know that it's 60,000 square kilometers. So that's great when you've forgotten calculations. But you might want to do something a little bit fancier. So I get a lot of questions about, I need the convex hull, something like that. So if you want to do something like a convex hull, and that is going to be the smallest polygon that can be drawn around all of our points. So if you're doing like a quick trade area type of thing, and you've got points that are of interest to you, we're going to use the magical ST convex hull and pass in our geometry. And we're going to see how unexciting this is. Oh my gosh, look, it's a bunch of convex hulls. You know what the convex hull is of a single point? It's a single point. So it turns out what you have to pass into that function is an aggregation. You need a multi-point. So we have another option for writing these queries, which is the RawSQL ag. So that's saying aggregate up multiple rows and pass something back. So I am collecting up my data points using st-collect. It's saying grab all these individual points, smush them into one multi-point, and then give me the convex hull. And that's going to give me something a little bit more satisfying. What's even cooler is you can define the level of detail for this dynamically. So here's the convex hull around all of my fire stations, but I might know something like, these fire stations right here, they're kind of interesting and they form a little group together, so I'm going to go ahead and use the Tableau function to create a group. And then my convex hulls are going to update. I love doing this. This is like my favorite thing to do in Tableau, because you can define the level of detail for those aggregations dynamically. Or if you already had something that you knew you wanted to group by, maybe I wanted to group by something like construction year. I have no idea what this is about to do. Let's see if I can do this on the fly and make it so it actually works. Yeah, we're totally grouping by construction year. But you might have more interesting things to group by in your data set. But it's super easy. Yeah? Absolutely. And this is all in those blog posts. So what I'm doing is I'm using RawSQL ag. So that's saying I'm not just passing in a single row. I'm going to pass in a cluster of rows. Go ahead and give me the convex hull of a collection. So collect is saying take everything that has been defined as a group, squish them together. So instead of a single point, you now have something that's passed in as a multi-point. Oh yeah, you could totally, yes, can you change these things dynamically? Yeah, if you've got some parameter that reassigns like how things are categorized, yeah, go to town. It's just going to run the new query. It's awesome. I love convex hulls. I answer a lot of convex hull questions, surprisingly. Voronoi polygons, does anybody want to be able to draw like the polygon where it's like everything inside this polygon is closer to a specific point than anywhere else? Yeah, we want those polygons. So let's go ahead and drop those on the map. Cool. That would be around all my fire stations. You think I'm lying that those are around my fire stations? Let's just go ahead and drop the geometry on there. And maybe we'll color code them by facility name so it looks really cool. And we'll dual axis it and drop them on the top. Hey, they're all of my fire stations, and I know that this polygon up here is closer to station 41. Everything in there is closer than any other fire station. That's great to know, but we got this little problem. Turns out it's returning a multi-polygon. and it's just one big multi-polygon that I can't separate out. Totally sucky. But I'm going to show you the query for that anyway. I think, yeah, I meant to show it to you over here, but we just took that collection and we used ST Voronoi polygons. Super easy. But it just gives us a single multi-polygon. That's horrible. What I really, really want is to know I want each one of these polygons to know what facility it's attached to. How would we do that if it just returns one big multi-polygon? It's a great use for custom SQL queries. So this looks kind of gnarly, but it's really not. We're making some sub-queries just to make it easy to understand what's happening. I'm saying take all the points and collect them together into one giant multi-point. Now calculate out my Voronoi polygons, but then dump that multi-polygon into separate polygons. And then since those polygons are kind of stupid, they're just polygons, go ahead and join them back to the fire stations so that they know which fire station they surround. And then it's going to return all of that, so I now have a table that's going to have a polygon for each fire station. Otherwise, I would just have the single multi-polygon. And then we can use that, and we could do cool calculations against it, because I have a polygon. So let's do a quick calculation. So I've got this custom SQL query that's now given me those new polygons. I'm going to take some fire incidents. I'm going to go ahead and drop that in. We're going to take our new geom Voronoi. We're going to combine it with the geometry from our fire stations. We'll do a spatial intersection. So now we're letting Tableau do what Tableau does well. I'm going to add in all my fire incidents, and now I want every fire incident to tell me which fire station is closest to it. Easy peasy. Let SQL do what it does well. It made us some new geometries. Let Tableau do what it does well. It just did a spatial intersection for me. You could totally have done that spatial intersection in part of your SQL query if you wanted to, but then you would have to figure out how to write it, and your query would just get longer. Tableau is really good at it. Why bother writing it? Unless it's like an integral part where you need that as initial SQL, just let Tableau do what it does well. Easy calculations. Let's do some other fun stuff. So we've calculated a bunch of things. Let's take a look at this example of doing some polygon on polygon intersections. So we're going to start getting more complicated. This is the equivalent of doing some things with multiple tables talking to each other. So first thing, let me show you what I've got for this data set. It is just a counties data set that lives in my database, and I have set it up so I've got this really nice little parameter action, so I can click on a county and it selects it. You know, pretty exciting. It turns orange. That's great. So let's write some queries against that so we can actually use it. First thing we're going to do is we're going to create a buffer against that, and I got to switch over to my cheater sheet because I am not writing these live. We're going to go ahead and buffer a single county, and we're going to do that as custom SQL. So what I'm doing is I am just selecting everything from my table. I'm selecting the geometry of my selected, I'm getting a field that'll just be called geom selected, so I just have geometry for one single polygon, and I am calculating a buffer around that special selected geometry. But I only want to do it where the geographic ID matches a parameter that I've set. So what this is going to return for us is one single polygon with one really nice big buffer around it. That's great, but maybe we want to know something about the polygons that are actually around it, and maybe we want the rest of the map so we can click on it and actually change that buffer, since that's how the parameter is set up. So we're going to look at the buffer and its neighbors. So that's just going to be a slightly different query where we're now going to join in our counties, the rest of our counties. So let's go back to our buffer and neighbors. We'll edit that SQL query. It's doing exactly the same thing, except at the end, I'm going to join back in the rest of the counties. All of these queries are in the blog posts. So now I should have the buffer and its neighbors. I should totally have the buffer and its neighbors. We'll go ahead and just grab a different query because I think I jumped ahead of myself, but you know, whatevs. They're all queries. They will all happen. There will be results. What this tab was supposed to be showing is not only can we do that, grab that buffer, but we can then classify everything into I'm a neighbor, or I'm not a neighbor, or I'm just a county that's hanging around. And then I can click, select a new county, and have everything rerun. And this is the basis for being able to do any calculations comparing a selection to its neighborhood. So let me show you how that query worked, because I know I just kind of like screwed things up and like cut and paste a bunch of stuff, and you're like, what just happened? So this is the query where we're just saying, give me a selection, so give me a buffer around the county that's defined by my parameter. Now go ahead and select everything, and then this magic case statement is going to say, if a county in my data set intersects that buffer, call it a neighbor. If it doesn't, call it a not neighbor. If it happens to be that is the exact county, we generally just call that, you know, the county. And then we can use that, use it for color coding, and we can define our neighbors and our not neighbors. And we could change that query anytime we want. So maybe we don't want the intersection, but we want everything that's completely contained within the buffer. We'll do an stcontains. And now we're going to get a different query result. So instead of having that more generous anything that touches that buffer at all, now it's going to just show me everything that is completely contained inside that buffer. We could switch it around with parameters. We can compare those stats with our neighbors, because now that we've got definitions of my selected polygon, my neighboring polygons, I can create visualizations that tell me something about the characteristics of my selection and my neighbors to compare them. And then we can put them all together into dashboards. Let me just zoom out. And so now I have this interactive dashboard that will let me select any one of the counties and identify what is near it and how do they compare. And anytime I interact with the visualization, it'll automatically update. It'll run that query back into the spatial database and update all my visualizations. So those are pretty easy queries. Actually, it looks like a nasty query, but it's really pretty simple. I'm using a parameter in this case, so I can change to say, tell me everything that touches, or tell me everything that's within a distance, or tell me everything that intersects. And so I'm controlling the spatial operation and the result using parameters. Let me see, I think I have one more set of demos. And I got like 7 minutes. I'm just going to see if I can power through. Do I have anything else? 1, 2, 3. Those are all the demos that I put together. I'm happy to show you any other examples if you want to pull apart crazy things like how does routing work? We could totally talk about that. Otherwise, those are all of the examples that I wanted to show you. Hopefully you've seen that Spatial SQL can actually do some really cool stuff. It's just a matter of figuring out how to squish all those queries together in the right place and in the right order. But if you can do it in a GIS, you can probably do it in a spatial database. And if you can do it in a spatial database, you can probably make Tableau visualize it for you. Let the spatial database do the stuff that it's really good at, so those advanced spatial calculations that we don't do natively in Tableau. And then let Tableau do the stuff that it's really good at. So being able to take the results from that and visualize it in all sorts of creative, cool, different ways. Because you can bring in both the geometry and the attributes, and then filter, use parameters, hook things up with some actions, and when you need to, have the database update things. And when you don't need to, just let people run with the data, run with their dashboard. So that is like probably a fire hose of a lot of different stuff. Remember, we've got blog posts aplenty And there are actually data sets attached to a lot of these with instructions on how you can get them into either your SQL server or your Postgres database. And then all of the step-by-step instructions, including things that I didn't show you in detail, like the k-nearest neighbors problems. Have at it. Let me know if you have questions. If you do really, really cool things, you should totally let me know. And I will help you showcase them on fabulous social media sites like Twitter. Me and my big bad follower group are going to love everything you do, which means that I'll send them to Kent Martin, the PM of the Maps team, and his big bad follower group is going to be really impressed. And my follower group is going to be like crickets. But I will totally get them to people who have actual followers. So if you have questions, I think we're a small enough group. We can just, kind of chat. We can talk up here. I'll walk around. It's the last session, so I know you guys don't have anything to do after this. So we can totes hang out. Okay. Thank you, guys.